Hello everyone, welcome to this online course on manufacturing process. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So we are discussing, we have already in this series, we have completed casting, we have completed welding, and now the last section of this course we are covering, that is metal forming. In metal forming, we are discussing bulk deformation. In bulk deformation, last three lecture we have discussed about the forging operations. Okay, so in forging we are continuing that one. So far we have discussed open die forging and closed die forging in detail, and also we discussed about the flashless forging. Today we are going to discuss about the forging hammers, that is the means through which we apply the force to deform the material, and then we'll discuss about the different presses used. So in this hammer we know it load will be actually sudden. So if we are hammering something, so load will be uh, suddenly applied. Load will be sudden. It will not be a gradual loading. So presses are generally used to apply the gradual loading. And then we'll also discuss about the die and what are the technical terms over there. So one by one we are going to discuss about this one. So we'll start with the forging hammers. Okay, types of hammers and what happens actually when we are deforming the material through the forging hammer. Then we'll see different die terminologies or what is the meaning of die and all. And then we'll discuss about the presses. Means if we have to apply the forces gradually, then presses will be used. So in this one also different type of presses we are going to discuss about. Then two more forging operations we are going to discuss in this one. One is offset forging and another one is roll forging. So we'll start with the forging hammers. So forging hammers, then presses and dies. Okay. So the diagram is also there. So we'll try to understand what is the meaning of hammer. We all know that whenever we have to deform a material by a forging operation, so what generally we do, two dies or the platens will be there. For example, if we'll show through diagram, so suppose this is a material we have to deform. So these two die or the this platen will be there, platens will be there or dies will be there, in between workpiece there. Now we'll apply forces from both sides. Suppose this is fixed here, so what we'll do, we'll apply forces from this top. So what will happen, will come down. Now how to apply these forces we can apply by a hammer. Means suddenly we are applying the force, so that will be impact loading actually. It will not be gradual. Another way through which we can apply the forces is gradually we can apply the forces. So these two terms are there. Hammer, whenever we are using hammer to change the shape and size in forging, means hammering the specimen, then it will be a sudden loading. Means suddenly we are applying the load or the force on the specimen that we have to deform. And if we are using presses, different kind of presses are there. Mechanical presses are there. Hydraulic presses are there. So through that we'll apply the load gradually. Means we'll gradually change the dimension or the shape of the material that we have to change. Okay. So what is hammer? So hammer operate applying an impact loading. Sudden load will be applied. Okay, on the workpiece. This is also called as the drop hammer. Means you are impacting then taking it further and then impacting. Means drop is not a continuous. Means you are impacting the workpiece or the specimen that you want to deform. That is the reason it is also known as a drop hammer, owing to the means of delivering impact energy. Yeah. When the upper die strikes the workpiece, the impact energy applied causes the part to take the form of the die cavity. We already know two dies will be there, so whatever the shape or the impression over there inside the die, when we'll deform the material, it is going to completely fill those impressions of the area over there in the die. And once this deformation will be over, it is going to take the shape of that impression or shape of that particular cavity given over in the die. Just like mold cavity in casting, already we have seen when the material we are pouring over there, so whatever the shape is there that we have created in mold cavity, exactly same shape or size our cast product will be there. Similarly here, we are applying the forces to deform the material. When material is in its plastic state, we know it will flow, and once it will start the flow, it will go and fill the whole area over there, and in that way it will take the shape of whatever the impression is there inside the die, or whatever the cavity we have created that we want in our final product. Okay, so that's what has been written here. Okay, sometimes several blow of the hammer are required to achieve the desired change. Yeah, that is obvious. If we are hammering the specimen, it's not necessary that in single hammer it will be completely deformed. Many of the materials we need to apply multiple hammer over there. Means we are striking, then taking, then striking, then taking, then striking. Just like blacksmithy in villages, you might have seen what they are doing. Once they are hitting the specimen, then putting on the anvil, and continuously they are applying the hammer over there. Means continuously they are striking on the workpiece to change the specimen. So that changing in the specimen dimension is not going to be accomplished in single hammer or single drop over there. Multiple drops or multiple times you have to apply the hammering. You have to hammer the specimen to change the its dimension or change its shape and size. Okay, so drop hammers, if you'll see the classification, it may be gravity drop hammers, it may be power drop hammers. Okay, gravity means we are simply lifting it. One, suppose this stylus is in my hand, okay, and it is some distance from the surface of where I'm sitting. So it has gravitational potential energy. From where this gravitational potential energy came? So from the surface, when I'm lifting this one, I'm doing work against the gravity. So whatever the work I have done against the gravity, that will be stored in this stylus in the form of gravitational potential energy. So once this has this potential energy, once I will leave this one, so the whatever the potential energy is stored in this one, obviously it will be converted into kinetic energy, because this stylus, when it will come down, it is going to gain velocity. It's going to gain a speed. As it will come down, its velocity or speed will increase. So whatever the potential energy was at a particular height, once I'm leaving it, that completely will be converted into kinetic energy. So if we are doing hammering on a specimen to change its shape and size only because of this one, means we are using gravitational potential energy, then it is known as gravity drop hammers. Means only because of the gravity we are doing that. And another maybe that is power hammer. So gravity drop hammer means their energy by the falling weight of a heavy ram. Yeah, it is falling, some weight is there at a particular height, it has potential energy, and it is falling down. So whatever the potential energy is there, it will be converted into kinetic energy, and that kinetic energy will be used to deform the material. So whenever there is change in the velocity, so already from Newton's second law of motion we know F is nothing but rate of change of momentum with respect to time. So if velocity is changing, no need to tell, although the mass is constant, but velocity is changing as it is coming down. So there will be change in the momentum, and this is nothing but force. So that force will be used to deform the material. Okay, is dependent upon the height of the drop and the weight of the ram. Power drop hammers accelerate the ram by pressurized air or stream. Okay, we can apply the force by different ways also. If we are doing by pressurized air or steam, then it is known as power hammer. So there are two types. First one is gravity drop hammer, or it is power drop hammer. Okay, next is presses. Different kind of presses are there. Presses, as I told, if we are hammering the specimen, means suddenly we are applying the load. But if we are using presses, different presses we are using to deform the material. So what is the main difference between these two? In presses, the load applied, the load we are applying, it will be gradual. It is not going to be sudden. So the force is given to the a specimen will be gradually, and it will not be like a sudden force. Okay, now just like it was in the case of hammer. Okay, so actually this is having three types. It may be mechanical, it may be hydraulic, it may be a screw. Okay, so mechanical presses means in these presses the rotating motion of a drive motor is converted into translational motion, okay, of the ram. They operate by means of eccentrics, cranks, or the knuckle joints. Mechanical presses typically achieve very high forces at the bottom of the forging stroke. Okay, now so it may be mechanical, and how it happens actually. So there'll be conversion of the motion over there. So whatever the rotational motions are there, it will be converted into translational motion, and when it will be converted, then it will be applied over there to change the shape and size or the dimension of the specimen. It may be of second type also. Hydraulic means directly we are not going to apply. Suppose I have to apply force on this one to deform this one. If directly I am applying the force by touching this one, then this will come under the category of mechanical. But instead of directly applying the forces, what I will do, I will simply place this stylus somewhere, and then liquid will be some type of liquid will be surrounded through this one, and now I will apply pressure in that liquid. So that pressure that I am applying or the force I am applying, it will be transmitted through the liquid. Here also we are applying the force, but the thing is directly we are not applying. What we are using, we are using an intermediate medium. That intermediate medium is actually a liquid. Through that we are applying the force. It will come under the category of hydraulic press. Hydraulic presses driven piston is used to actuate the ram. And the last one is, that is a screw presses. It apply the forces, force by a screw mechanism. Okay, that drives the vertical ram. Both a screw drive and hydraulic drive operate at relatively low ram speed. So what is the difference? If you are using mechanical, so here ram speed will be very high. But if we'll take these two processes, I mean two hydraulic presses and a screw presses, the relatively the speed of the ram will be less if we compare with the mechanical presses. Now, what this forging die, what are the terminologies? So different terminologies are there in this forging die. So here is the diagram we can see. This is the one half of the die, and this is the second half of the die, and this is the workpiece or die impression where we have filled the specimen and then we applied the force. Finally, it has taken the shape. Okay, so different terminologies are there. One by one, we'll see what are the main terminologies of this one. So first one is parting line. Parting line means the line divides the upper half from the lower half. In other words, it is the plane where the two dies half meets. Okay, na? The, so you can see here in diagram where is the parting line. So this is the one half and this is the another half. Okay. So where they are meeting, this line actually is known as parting line. Okay. So this is the first one. Second one is draft. It is the amount of taper given to the sides of the part required to remove from the die. So once, just like casting also, in casting already we have seen different allowances will be given over there. So draft allowances was also there, so that after casting we can easily take out the product from the cavity. Okay, now similarly here, what is happening, once material is completely forced over there, it has taken the shape of the die and everything. So if that allowances will be provided or the draft or the angle will be provided, so that once the process is completed, easily we can take out the product from the die. So this is known as a draft allowance. Draft. This is in the angle means some slightly tilting will be there from the vertical. So we can see from the diagram. You just see here. This is the inside tilt. We can see from the diagram. This is a small angle. Here this is the outside tilt. If you see carefully, here this is slightly tilted, and this one is also slightly tilted in backward direction. This one is slightly tilted in forward direction. So this is the draft is provided, so that once the forging is completed, easily that forged product can be taken out from the die. Next one is die angle. So die, this is also die angle. Now next is waves and ribs. Just see the diagram where the waves and ribs are. This is the rib and this is the wave. What is the meaning of this one? So waves and ribs, they are thin portions of the forging, that is parallel and perpendicular to the parting line. More difficulty is witnessed in forming the part as they become thinner. So we can see here these are parallel. Okay, so this is the rib and this is the wave. So this is the parting line. This is the parting line. So we can see these two lines are parallel. And if you'll see this rib, it is approximately perpendicular to the parting line. Okay. What is the next one? Next one is fillet and corner radii. A small radii limits the metal flow and increase stresses on the die surfaces during the forging. It's quite obvious. So we can see here where is the corner. Here is the corner is. So if the radii or the fillet is very small, no need to tell what will happen. It will limit the metal flow, and if metal flow is limited, means it is restricted. So what will happen? There will be more stress on the die. Okay. Next is flash. Flash is actually the extra material. Sorry, flash is actually the extra material. Once we'll do this forging operation, so what will happen? this material will start to flow and it will take the shape of the die. And whatever the extra materials are there, so beyond die also it will come out. That extra material is actually known as flash. So you can see here this shape has been generated and this extra material which has come out at the outside, that especially place is provided for that one, this is known as flash. So this is the extra material. Once the material has been deformed, and when this extra material is adjusted, there's actually the special space is provided over there. So this is known as flash. So these are the some of the technical terms which is generally used in a die. And next is other forging processes like offset forging. So we have already seen this one, offset forging. We have already seen what is the meaning this one. Whenever we are increasing the cross sectional area and we are reducing the length of a specimen, this is also known as offset forging. So through diagram we'll see this stepwise. If we are telling this is step 1 and this is step 2 and this is step 3 and this is step actually 4. Sorry, let me write this at the bottom. This is a step 4. So these are the 4 steps. So stepwise we will see. It is a deformation operation in which a cylindrical workpiece is increased in diameter. We have already seen if a specimen is there, this is the specimen, and we have already seen in open die, we discussed this term. If we are applying forces, suppose forces we are applying from the top and this is the area which is fixed, so what will happen, the length of this specimen or height of this specimen workpiece, suppose this is h, will decrease. And once it will decrease, we know volume of the material will remain constant. So what will happen, this cross sectional area actually will increase. This specimen cross sectional area, this is going to increase. If this is the case where the cross-sectional area of the specimen is increasing on the cost of its height or length, it is known as offsetting. So here also what is happening, the workpiece is in cylindrical shape. So when we are deforming this one, so what will happen, its diameter will increase with reduction in length. Okay. In industry practice, it is done as a closed die forging. Okay. Closed die forging means it will be, this is also known as impression die forging. So it material will not be free to move, means its movement will be constricted over there, and finally it will take the shape of the impression over there. So offset forging is widely used in the fastener industries to form heads on nails, bolts, and similar products. Just see here, this is the one half and this is the another half, and this is our specimen and this is the punch through which apply the force. So this is the first part. In second part, what happens, both die now is in contact with this workpiece, and this is the ram or the, so this is the first step of this one, this is the second step, this is third and fourth one. So what is happening here, this is our specimen that we are going to deform, this is the specimen we have to deform, and here what is happening in second step, now all these three are in contact, and this is the punch through which apply the force. Just see the last, this third stage, what is happening, now this punch is in contact with this one, and what is happening, it is applying the force. So whatever this specimen is, this specimen material is, it is going to take the shape of this one, it is going to take the shape of this one. So you can see here a little bit bulging shape is there, bulging out. Obviously there will be friction in this area, there will be friction in this area, and here also there will be friction. So what is happening, this deformation is not going to be homogeneous, obviously, because of the friction. So it will start bulging over there. But finally, what will happen? This material will start to flow in this, the wherever this part is provided. Okay, and finally, once the complete flow will be stopped, means it will take the shape of this one, and finally it will look like this. So what this process is actually, this is for creating heads on the nails. So you can see here this cylindrical shape is there, and what one end of this cylindrical shape, this head has been created. So there is no flash here. If we will tell, this is also like a flashless operation, because there is no flash generated here. Whatever the material was, finally it has taken the shape of this one. So this is known as offset forging. So offset forging simply means we are increasing the cross sectional area and we are decreasing the length. As we know, there will be volume constant during the deformation. It doesn't matter whatever the metal forming processes we are using. In all the processes, volume will remain constant. So if one dimension is increasing, obviously to compensate that, other dimension will decrease. Okay. So here cross sectional area is increasing, obviously length will decrease. The second process that we are next process that we are going to take is roll forging. Roll forging, no need to tell. Whatever the forces is required to change the shape and size or to deform the material, that will be provided in the form of rotating rollers. So just see this one. This is the one roll and this is the another roll. These two rollers are rotating on its axis, and in between we are putting our workpiece that we are going to deform. Okay. So it is a forming process used to reduce the cross-sectional area of a cylindrical or rectangular rod. If this is the cylindrical rod and we are putting inside between the two rollers, so what is happening? Compressive load is coming out from both sides. From both sides there will be compressive load, and because of this compressive load, just like rolling, thickness will reduce. Here, what will happen? Overall, these rollers are rotating, so everywhere the pressure will be same, and what will happen overall the cross sectional area of the specimen will be reduced. So in this one, of a cylindrical or rectangular rod passing through it, a set of opposing rollers, means they are of course rotating in opposite direction, so that its tendency will be to pull the specimen inside this rolling rotor. So because of friction, it will take inside, this part will go inside and it will reduce its cross sectional area. Okay, matching groups are there, have the matching with respect to the desired shape of the final part. Okay, it combines both rolling and forging. Yeah, definitely. Forging means applying compressive force and deforming the shape, and the rolling means without any force, it's simply because of the friction it is taking, and what we are doing through the rollers, we are deforming the material. So if we'll see this process, it is combined form of this rolling and forging. Okay, but classified as forging operation, but generally it is called as, it is a roll forging operation. But if we'll see the working, if we'll see the mechanism, both things are together simultaneously, both things are happening. Okay, depending upon the amount of deformation, roll rotates partially. Yeah, how much force will be required to deform according to the nature of the material, and obviously what is the initial thickness or what is the initial dimension of the specimen, it will be decided at what speed the rollers are going to rotate. Roll force parts are generally stronger and possess desired grain structure compared to the machining might be used to. Yeah, so if similar thing, suppose I have this specimen cylindrical, okay, specimen, if I have to reduce the cross sectional area by 2 mm, I can do through lathe also. I will simply turn this specimen on lathe, and if it is suppose 10 mm and I need 8 mm of diameter, what I will do, 2 mm I am going to turn off over there. So through lathe also we can do. Another thing is we can do through this roll forging. But what is really the main difference in machining? The problem is its property is going to be reduced. So whatever property is already there, definitely it will be reduced over there because of the heat dissipation or heat generation during the machining. But this is not the case with this roll forging. If we are doing this roll forging, so forget about the reduction of the property, its mechanical property will increase actually, because whatever the defects will be there because of the primary manufacturing processes through which this specimen or part has been manufactured at the starting, this roll forging will act as a secondary manufacturing process of that one. So whatever the defects will be, definitely it will be removed, and moreover that its microstructural feature will improve, means grains will be refined, and because of that almost all the mechanical property including strength will be better if we compare with the initial product. So that is the advantage of this process. So we'll stop this lecture here, and next class we'll take some other process where related to this bulk deformation. Thank you.